So welcome to another session. In this session you will learn to calculate or to compute the infinite geometric series. So imagine you have a series which is like this: s is equal to 1/2, or s is equal to 1 plus 1/2 plus 1/4, and so on and so on. You can see that to represent this graphically, we have a paper and we divide it to half, and the first one was 1, and now we are adding a half, and again we divide that half to another half, and again we do the same thing to the other remaining half, and we do the same thing to the other half, and we continue to do that to infinite level. So in this case we are adding all element but for one infinite geometric series. So the question here is how we can do that. So imagine you have a ratio r which is bigger than -1 and less than 1. So for example, take for example 1/25. R is equal to 1/25. So my Sn from my formula that we know we derive from the previous video, we can see that my Sn will be T1, which is my first term, times 1 minus R to the power of n divided by 1 minus R. But because my R is 1/25, and 1/25 to the power of a very huge number, for example 10,000, this number gets smaller very quickly. So as when you have your ratio R to the power of a very very big number, the whole thing go to 0, and you can try that and you will see it. So for this equation, my R to the power of n will go to 0. So where I will end up with Sn is equal to T1 times 1 minus 0 divided by 1 minus R, which will give me T1 divided by 1 minus R. But be careful, we choose here our R to be between -1 and 1. So to have this number go to 0, my R should be between -1 and 1. And in that case, my infinite geometric series can be calculated, and we can find it using this formula. However, if my R is less than -1, or my R is greater than 1, we cannot find the infinite geometric series, because my series will just diverge to a very large number like this. When I am keeping I keep adding element to each one, my series just get to diverge to a very big number, so we cannot find the sum, and we can just say that my series diverge. And when I am able to find the limit or the sum of my geometric infinite series, we can say my series converge to a finite number. So let's us take one example. For example, the question is asking us decide either the following series diverge or converge. So we have this geometric series and we need to decide, is it a diverge or converse series. This is the first one. The second one is this one, 2 minus 4 plus 8, and so on. So the first thing we will do, we will check how much is my R. So to find my R, I will divide two consecutive elements, and I will find my R. So my R is 1 over 3 divided by 1, which is minus 1 over 3. So, and because my minus 1 over 3 is greater, or is between minus 1 and 1, I can say yes, my series converge, and I can find convergent, and I can find the sum. So to find the sum, I can write my S infinite geometric series sum is equal to T1, the first element, divided by 1 minus R, which is, the first element is 1 divided by 1 minus 1 over 3, which is 1 over 4 over 3, which is 3 over 4. So I just find my the sum of my infinite geometric series. However, in the second example, for the second example, R is equal to minus 4 divided by 2, which is minus 2, and minus 2 is less than minus 1, so I can directly go ahead and say the series is divergent and has no sum.